Okay, hello and welcome to another episode of Between Two Nerds in Isolation still, where if you've seen this before, you'll know that normally we invite a small human being to come and sit in between us. Well, sitting in between us is a physical impossibility at the moment, and we have briefly run out of small human beings thanks to isolation. So for this episode, we have decided that we will engage in a scientific debate conversation that, if we're honest, myself and Mo have had a few times and continue to discuss. So we will share it with you and drop a comment down below if you want to join the discussion or if you err to one side or the other. Mo, over to you to introduce Mo.
All right, guys. So you know the nerds. I'm Mo.
And I'm Eugene.
Okay, and Mo has a slightly better setup since I don't have kids, and I could get a green screen and get our fancy mics plugged into the computer.
Yeah,
Eugene.
Mo's got more time than me. Eugene's in a house with 3 children and a wife, and is lucky to manage to get the spare room for half an hour, let alone the green screen. So Mo probably sounds better. Arguably looks better in terms of his background at the very least. But we'll crack on. It's fine.
Yeah.
Doesn't bother me. Sound a bit tinny.
Yeah. So okay, so here me and Eugene, or Eugene and I have had this debate at least once for sure, right? Where we actually debate, well, it has to do with extraterrestrial life and the likelihood of finding extraterrestrial life, but not just any sort of extraterrestrial life. We're really talking about intelligent life, like the little green men and women that we all hope that just discovers at some point. Now, I'd
take an alien dog, by the way. It doesn't have to be a little green man or woman.
Just intelligent.
Dog,
yeah, I mean,
cat.
Yeah, as we were thinking about this, I was like, yeah, it could be a dolphin. Like, I mean, highly intelligent, right?
Well, everyone knows there's alien dolphins.
But yeah, but or was it the whales from Hitchhiker's Guide to the Galaxy?
Yeah,
dolphins.
Yeah, it's dolphins. Dolphins.
Yeah, love that book. Books. And so I have a more, I guess, pessimistic view about it. Yeah. Well, actually, I don't. I am hoping that there is intelligent life out there, and we do contact them. We meet them in whichever form. Yeah. So, but I guess I'm playing more devil's advocate here.
Well, I think you were right with pessimistic. I'm much more optimistic. Sure thing, as a banker.
Okay, Eugene, why do you think it is more leaning towards certainty?
Okay, scale is number one. So we're talking about in the universe. So if we're just talking about intelligent life being somewhere in the universe, for a number of reasons that I'm sure we're going to mention, I'd say it's pretty much, in my mind, it's almost certainty.
Yeah, I've worked this out actually in our classes. So there's like lower end of 100 billion galaxies, that's 11 zeros, times about, let's say, lower end 100 billion stars in each galaxy, another 11 zeros. On average, that's our planet, our sun has 8 planets around it, so let's take half of that, so that's 4. So that's what, 4 with 22 zeros after it, whatever number that is. 40.
That's a big number.
Septillion? Right? Something like that? No, or hexillion.
Hexillion.
Hexillion, yeah. 40 hexillion, something like that, right? Yeah. Okay.
It's a lot.
Yeah.
So that gives me a sort of sense of certainty that there is life out there. I'm sure we'll come on to it, but if there's life out there, I'm pretty sure there will be intelligent life out there. Now, where we've introed this is, will we find it? That is less of a certainty because of the scale of the universe and our current ability to reach out, even within our galaxy, let alone in our universe.
Yeah, we're limited by the laws of physics, right? Like
we are. They are pesky little law that gets in the way of things. But at the same time, I'd say if you scale it down just to our planet, I mean, we're one planet, and there is a cacophony of life on our planet.
Good word.
And we're a pretty new planet. We're 4 billion years old, 4.5 billion years old. So there's been life for the vast majority of that time that the planet's existed.
Not only that, it's like pretty much as soon as life could exist, it came up pretty much, right? It's about 4 billion years ago.
Yeah. So
I'm throwing a few your way. Yeah. Yeah.
And then so if you then look at where we're exploring and where we're looking and the bits that we can see, which frankly was not just our solar system, but we see our solar system in ever increasing detail. We are enthusiastically, proactively, and the best scientists on the planet are enthusiastically and proactively hypothesizing that life could, maybe should exist on planets. Well, if you take Mars, we're looking to see if life existed on Mars. If you take some of the moons, they're proving to be vastly more interesting than some of the major planets. But the moons of those planets look potentially like they're ripe for life. And then we've got where people can do it at home. You can go on your computer and you can search the solar system for planets that are, from the little bit that we can see, potentially suitable for life. So in terms of the number of places to look, everywhere we look, we find more places to look. So that just increases and increases the chances. Okay. So it's a banker.
This is my rebuttal.
I haven't found it yet.
Yeah. So, but what you're saying there, like, okay, so there's like two schools of thought that you have to approach this with. It's the places where you can find life, right? Versus the probability of life. Now, life, I think, we'll easily find it. I mean, within our galaxy, at least, easily we'll find some sort of life, microbial or otherwise, right?
Yep.
But I think it's more like multi-cell. Maybe, okay, let's not go even, okay, if I say intelligent, I'm thinking more of
an animal.
Yeah, it doesn't have to be like a human, right?
Yeah.
But even if we found an equivalent of a chimp, even if this animal, this life didn't have a space program, I would still count it as intelligent life.
I hope so, because if someone was looking at us 100 years ago, I'd hope they'd call us intelligent life.
Yeah, exactly. So I don't. It's not the space program. That's not a requirement, right? But okay, so intelligent. Well, where would we really start that off from? I guess multicellular life, right?
Yeah, complex life.
Yeah.
So complex life. Now, if you get to the point where you're looking at a degree of culture or socialization, so I would say there's culture. If you take an orca, so if you study orcas, they have culture. So you study those, that's intelligent life. Now they're not.
And they teach their young. They do all sorts.
Absolutely.
So I would include that. But I'm thinking more like, so the arguments, the way I'm arguing against, I'm saying it's less. Okay, so if you take that huge number, 40 hexillion, right? Then that was just planets, right? Now you have to add, in the past, we'd say, okay, this has to be a Goldilocks zone. So maybe we can take out a few factors out of that, right? So, but obviously that doesn't, because we find life thriving in the most hostile places here on Earth, right? Within volcanoes, near hydrothermal vents, it doesn't matter. So, okay, we can stick to that 40, whatever number, big number.
Yeah, the big
but
one.
Then that one, we haven't even added the moons. And when I gave that number, that was the lower end anyway.
Yeah.
Okay, fair enough. I'll give you all of that. There's lots of places to look. And that's where an astronomer or an astrophysicist would approach it. Because, okay, let's say, even if we're just talking about intelligent life or complex life, there's just so many places to find it. But surely the number is massive. But what we have to, where I could, from a biological perspective, though, like,
Yeah.
okay, there's so many milestones that had to, these major milestones on the way to in complex life that had
Yeah.
to be achieved, right? Okay, so the
Yeah.
first one is, I guess you could, I mean, okay, so there's two ways, I guess there's two schools of thought of where you approach this, whether it's the information one or the energy side. So information is
Hmm.
like, first thing you need are replicators like DNA or some proto DNA, let's say,
Yeah.
proto RNA even. Or you want, so that's one school of thought, that's the first thing you need. Or the second school of thought is energy, because all the yeah
Sorry about that.
happened. Yeah, so all the yeah, so it's how they're getting their energy, basically,
Just
right?
going to close the door one moment.
Yeah. Life in lockdown. Yeah.
Right, so
Yes.
you've got information
And there's
and you've
the
got
energy
energy.
way,
Yeah.
right? Okay, so first, the probability of those self-replicating molecules. Let's take the information path.
Yep.
There's a certain amount of probability that arises naturally, right? So there's that one. Then there's developing, I guess, a protective membrane. There's a probability that happens in the first place. I guess
Yep.
that one's pretty straightforward. But then there's, in every step of the way on these milestones have a certain amount of probability, and the numbers there are so improbable that they counteract
Yeah.
the huge probability, the huge possibility of places where life could exist.
Yeah.
Especially, I think one in particular, there's like it's like the most important milestone that had to have happened for complex life, which was they call it endosymbiosis. It's when you have these early molecules, one of them kind of swallows up this other one that was
Yeah.
really good, like the, let's say, proto mitochondria, which
Yeah.
is basically the power station of our cells.
Doesn't kill it.
It swallows that one. Yeah, instead of digesting it as it normally would have,
Yeah.
they somehow learn to survive together. And from that, you have this amazing cell that can do so much more now. So you have your first eukaryotic cells.
Yeah.
Now, that one, scientists think that has happened. Although we've had life, prokaryotic life, for billions of years before this moment, scientists still think that that's only happened once and that's it. And all life, yeah, I know. But as far as there's a really good book about this. It's called The Vital Question. And there was a very good reason why, but they can basically trace all of it back to this one instance when it happened. So it hasn't happened more than once. Now, if there's life all around the planet, okay, and so there's so many chances. Think of the number of microbes, right? Number of prokaryotes that were going about. And if it's true that this has only happened this one time, and from that you have eukaryotic cells,
Yeah.
then that's astounding. That's like a
huge.
So so before we had a 10 to the 22 number, right?
Yeah.
Right. So this is like a 10 to the minus 20 something. I mean, whatever the number is. No, obviously no one knows the actual probability. Yeah. Just the fact that it's, and then that's just one. That's a major hurdle, right? And then there's so many other things.
Hurdle, why do we say it's only happened one time?
Yeah, that first time that it happened. So it only arises that one instance.
Yeah.
Once, right? Yeah, after that, that cells replicated and made loads.
No, but it might have happened again elsewhere, but that's not going to necessarily...
But there's a reason why. Yeah.
There's a reason why a dandelion throws out 1 million seeds, because 999,999 of those seeds.
No. I get it. But there's whoever the scientists that study this, right?
Mm.
For some reason, I don't know why exactly, right? There is a reason why they think that this, as far as they can tell, this has only happened once. And all the eukaryotic cells that we have now, right, that make us up and all other multicellular life pretty much, can be traced back to that one instance when it's happened. Maybe there's something about, I don't know, like if even if it happened another time, those cells haven't survived because they don't have, because all eukaryotes are pretty much work the same. I mean, except for like minor differences like cell walls in plants and little things like that, but we have the same energy pathways, we have the same, there's all of these other little things. So they think that that's why they think that, as far as they know, no, but we can only work with the numbers given. So I actually am I think I lean more towards, I think a part of me, because I have the high creed, is like, I really want to believe, right, that there is intelligent life out there. I really do. So I would probably say that maybe it's like, I think the numbers kind of might balance each other out on either end. And we're looking at maybe a handful of times in the universe, right, that we have in, I know, I don't want to, I wanted to be like, no, it's everywhere.
But this is all based on that is as rare an event as we think that is. Now,
but that's one example. I think that is the big example, the major milestone. But there are other milestones, biological ones that.
But we don't know if that hadn't happened a million times before the one that took, and a trillion times since then. But it's now happening. If it happens since then, it may be happening in an environment where.
But we can't see that branch though. If it happened another time, but we can't. There must have been some reason that made them less fit to survive, right? So it wasn't good enough that whatever happened, they weren't fit enough to actually make it to the point they also turn into intelligent or complex lives.
Yeah.
So that's why. But obviously now all we can do.
So we're 1 for 1.
Yeah. So I know you bring this up. So it's like the one place we've looked here on Earth, there's intelligent life. So batting a good average, right? But it's like telling you about I can't remember his name. He was on Sean Carroll's podcast. So he was saying that even if, which is a really cool, like little, well, I never thought about it before brought this up, but like, if we found life on, let's say, Mars, right?
Yeah.
Now, what are the chances? There's two ways to look at it. Like, oh my God, we looked on two places and we found life on both places, right? Yeah. But he had this other flip side to it, which is great. Like, it's like, that's a really good point. Like, what are the chances that we found life right next to each other, right? Right by each other, okay? So his take on it was, there is such a good chance that this was just cross-pollination or panspermia between the two, because we get meteorites exchange between Mars and Earth all the time, right? Not all the time, but in the history of our planet, a lot. So if we found life there, it's not as groundbreaking a thing as finding life on one of Jupiter's moons. Like, the further out you go and you find life there, now you're like, okay, this has to be like an independent event.
Yeah.
Right? If you find it on Mars, now there's always going to be that question, like, oh, did it come from, especially if it's very similar to sort of life on Earth. Like if it has DNA or RNA and those kinds of things, you're like, oh, come on. Like, what are the chances?
You'd have that niggle. I get that you'd have the niggle in the back of your head, but I mean, to get from here to Mars, the probability of that must be not far off what we've discussed at every other point of probability.
Yeah.
So there's the common sense argument that the universe is massive. You look next door to the closest planet you've got, and Bob's your uncle found life. It must have travelled there like the iguanas crossing oceans.
Yeah.
It's still pretty unlikely. It's still a long way. It's still a vacuum of space. So it's for me, if we found life on Mars, I wouldn't let that burst my bubble
No,
at
I
all.
wouldn't. I wouldn't either. I wouldn't either.
I
You know,
think,
in this debate, I'm on your side. By the way,
yeah,
I'm just playing devil's advocate. That's it.
I think we're, from what I know, I think I'd be much more excited about exploring further, deeper into our solar system
Yeah.
in the hope of finding life. Just
Especially
space.
when you get to especially when you get to planets that are less terrestrial, like Mars, right? Mars is
Yeah,
pretty Earth-like, or was, right? So, and
absolutely.
it's not that bad, right? But if you go to like, so you're saying before Enceladus,
Yeah,
before we started recording, Enceladus, or even Titan, I think so. The
yeah,
same thing they had was on. Yeah, so Enceladus, so there's water, right? So now
yeah,
now there's a chance there that the life that you find on Enceladus would be very similar to, because it needs water and it could be
yeah,
carbon-based life forms, right? So very similar to the Earth-like life, a terrestrial life. But if you went to something like Titan, so it's more exciting about exploring Titan because so there's methane there that exists in all three states. So
yeah,
you have methane ice, liquid methane, and methane gas. So, and it's a solvent, just like water is a solvent, but it's the opposite. So water is a polar solvent. That's why salts and things dissolve so easily in it, because it has an electric charge. But methane is a non-polar solvent. So all the chemistry that, if there was life, all the chemistry, okay, and it was dependent on methane as a solvent, all of its chemistry would be vastly different than the chemistry that we see
yeah.
here on life. So that's why I think it'd be a far more exotic type of life.
Absolutely. And that's so in terms of what that life looks like. So when you take it's back to the sort of, I think we mentioned this in another episode, but if you take our journey, so or planet Earth's journey to the huge sort of biosphere that planet Earth is now, it is, and you play the story backwards. Now, when you play a story backwards, you're only going to see your story. So you're going to get these crazy probabilities. If that didn't happen, this wouldn't have happened, this wouldn't have happened. That's to achieve what we see today. That's not to say if something else happened, we wouldn't be looking at something else today, or we wouldn't
Yeah.
be something else today. So when you go looking and saying the unlikeliness of complex life here and the biodiversity that we get, you can't apply. It's like what you just said. You can't apply our story. So if you go
Yeah.
to Enceladus, if you go to Titan, if you leave our solar system and go to the places we don't even know, life may be just as complex but totally unrecognizable and have a fundamentally different story.
Yeah.
I'd still imagine.
Or maybe there are, like, with different chemistry, there it unlocks easier paths to complexity,
Yeah,
right? That could happen. Maybe there's an easier way. Just we're burdened by water. I mean, yeah, but it's still like
possible.
it's the anthropic principle at play. Like, we see what we see here on Earth. We're like, surely it's like this everywhere
Yeah,
else, right? It's like when you go to a new country that has different types of what you have to eat with your hands here, not knife and
yeah.
fork, like little things like you don't think of other ways that you could possibly do things,
Well,
right?
that in our lifetime, that knowledge we've already referenced it has. So even in our life, certainly in mine, I've got an extra 10 years. But our understanding of what you need for life, we were talking 40 years ago, it's really simple what you need for life because we know
Yeah,
it. And it is, you need the oxygen, you need the water. Everyone knows what you need for life. But in those last 40 years, as I think we've mentioned, we found life in places where it doesn't tick all of those boxes. And we found life that can survive if you remove all of those boxes. To that, our knowledge of what makes the ingredients for life or complex life, we can kind of throw them out the window because we've already found just on our planet life that doesn't use that same set of ingredients, which
yeah.
makes it much more exciting to be storming around the solar system in
Yeah.
search.
I mean, I guess it would be amazing. Like, if we found some kind of life here that didn't require like ATP for energy
Yeah,
and anything like RNA or DNA for information, right? Oh, that'd be like, what? There are other possibilities. Yeah. That is, yeah, it could be. I mean, I guess that would be one of the theories, right? A hypothesis that it can't have come from this planet.
There was an exchange trip with Mars.
Yeah. But, yeah. I don't know. So I want to believe that intelligent life is likely. I just want to, because it'd just be cool. I think it's also for a more like not spiritual, but like at a deeper level, right?
Yeah.
Like as in like, okay, especially if they are in like life with the space program, let's say, right?
Yeah.
Then human beings, we don't seem that special, in which I know we are special, right?
No, I don't like the
But
specialness.
yeah,
All
but I
right.
mean, as far as we know now, it's one of those things that science communicators say, it's like it's the universe's way of studying itself, right? Because we are part of the universe stuff. But if it's happening more, I mean, obviously we're still special, right, to us, right? But if there are more, then it I don't know, like it's just been so much more interesting. I think that's why, because then in space, the universe seems more interesting.
Well, the great news on that is in our lifetimes, we're either going to find out that there's intelligent life or any kind of life out there. We're going to know that for a fact, or it's going to be just as tantalizing a prospect as it is today. And it will be kind of forevermore. So no one is going to at any point prove that actually, sorry guys, we're it. Don't mess it up.
Yeah, it'd be impossible to, right?
Yeah. So I cling to that.
Yeah, it'd be impossible. I mean, it's one of those things that I guess proving it right is easier than proving it wrong. Because if there is intelligent life out there, like with a space program or something, it's easier to get contacted by them than it is to visit every single planet in the universe and prove that it's
it's proving it right is easier than proving it wrong if it's right.
but I guess we would only ever be able to prove it in our galaxy, right? That sucks.
Unless something, I don't know what Elon Musk's got going on in the cupboard out the back.
I don't think it's going to be him.
No, it'll be in our galaxy. That's all. Certainly in the foreseeable, we're only going to see it. Unless, as you just said, something comes telling us about it, or telling us about itself. Which that bothers me, because why would it bother?
Or the only or the only thing that limits how far we can explore is the fact that, because let's say in a human lifespan or something, right? That's what. But if our next step in evolution is to upload ourselves into this electronic consciousness thing, and now time isn't a factor anymore.
Yeah, right? So
exactly. It's just but we've built that big Dyson sphere, which is the thing that covers the entire planet just to capture all the light from the sun. And we've built, there's another thing, the von Neumann machines, which are self-replicating machines that travel out, right, land on a place that they can find enough raw materials, and create copies of themselves, which keeps fanning out. And so now, I mean, they can do this because of exponential growth, right? You can explore the universe at much faster rates. And then, and if you are uploaded into this the singularity or whatever, right? Then, time's a factor. Then we can explore the whole entire universe.
That's true. And time is a biggie, because we're talking about, is there life? But timing is everything. There'll come a point where if the only life we know is on planet Earth, and it remains on planet Earth, there will come a point where there is no life. And we know that. That's basic physics and science. So we're either going to have to leave, or so we're looking at Mars thinking there may have been life. But when we look out, and you're getting into relativity here, but when we look out at the universe as we see it, we're looking at something that may have complex life that's taken 4 billion years to develop. Well, it may have developed by the time, from what we're seeing now. So, which in my mind just massively increases the probability. You got billions of years to play with.
Yeah, I guess so. But you've got. I'm still thinking it's not. I think I cling to. I'm hoping it is like a few within each galaxy.
That'd be nice.
Yeah, that'd be nice. See, I think that's where you can draw. I think a biologist might say, like, no, you might be lucky to find a few in the entire universe.
Yeah, no, they're wrong.
And yeah, what do they know about life? Those astrophysicists will think, no, it's look at the amount of chances it's going to be teeming with life, right?
Exactly.
Yeah, which is where the Fermi paradox comes in, and it's like, where is it then, right? But then you have. I would like to think, okay, let's not go with a handful in the universe. Let's say a handful in the galaxy. Come on. Give us that.
Take a handful of it. I think that's fair. I think that is fair.
That's like Star Trek, basically, right? There's like a few Klingons, Vulcans. I don't know if they're in the same galaxy, but whatever.
All in, yeah, what's a quadrant in Star Trek? Is that in the galaxy?
I don't know. But in Star Wars, they do say it's all happening in a galaxy far, far away.
Far, far away, yeah.
There you go. Proof.
Right, there you go. Done. Well, I think that's absolutely smashed the discussion.
Yeah, good place to end. Star Wars is canonical.
Perfect. So anyway, I hope if you have watched or listened to this, you've enjoyed that discussion. If you want to get involved, don't hesitate. Drop us a comment down below and we will have a read and try and respond. Or if this made you think of something else, let us know what that is.
Since we can have like this remote sessions, if you're a big enough fan, maybe we can have you guys on. Yeah. So get involved.
Yeah. So let us know. Get in contact. If you are new and you've enjoyed this, hit that subscribe button wherever it is. Certainly hit that like button. It makes us feel good. And wherever you are, if you're in isolation, I hope you are staying safe and washing your hands.
Yep, stay safe. Bye, guys.
We make the children do it.